Welcome back, physicists. This lecture will be about dimensional analysis and unit conversion. So we had talked before about different types of units. We had a meter, I got the wrong tool there. We had a meter, and we had that a kilometer was equal to 10 to the third meters. We had a megameter was a 10 to the sixth meters. We had smaller versions where a millimeter was equal to a 10 to the minus 3 meters, and a micrometer was a 10 to the minus 6 meters, etc. So this lesson is sort of about the math. How can we need a mathematical tool to go back and forth between these really quick. And you'll find that the nice thing about the metric system is that they're all in powers of 10. Now you may have seen the method where you simply move the decimal place a certain number of times if you're trying to go from one to the other, which is fine. That totally works. King Henry something or other. Although I will say that typically we're not going to use all of those in between, like the decameters and stuff. Not very common in modern science. We tend to go by these, if you look, they're going up by 3 powers of 10 each time. The exception to that for us is probably going to be a centi something. A centimeter is a 10 to the minus 2 of something, if you want to stick that in there. But a lot of times they stick to the 3 powers of 10 separation there. I just put megagram, look at that, and I didn't even notice. I meant megameter is a 10 to the 6th meters. All right, so dimensional analysis, if you've seen it in chemistry, this video is just going to reinforce all of that, but keep this in mind. So we're gonna assume that you have at least these prefixes memorized or can refer back to them. There are others, like you'll probably use nanometers, you might use giga, but I doubt it. But let's start with these basic ones. And they give you some measurement, and they say, oh, look, I've got a 2.35 millimeter wide something. What's 2.35 millimeters wide? Maybe the thickness of like a thick coin or something. Anyhow, and you go, well, how many meters is that? And because I'm dealing with a lot of times, let's say that you're going to take that object, you're going to throw it across the room, and it's going to have a speed measured in meters per second, and you can't compare millimeters to meters, so you need them to be in the same unit. So we'll do it like this. We'll take the number that you start with, that 2.35 millimeters, and we're going to multiply it by 1, essentially. Now, if you've never seen this before, here's how it works. If I took 2.35 and multiplied it by 1 divided by 1, I should get 2.35 back. That shouldn't seem hard. If I did 2.35 and I multiplied by 7 divided by 7, I mean, you could try putting that in a calculator, but you will get 2.35. Don't believe me, try it. And just to drive the point home, if you did 2.35 and you multiplied it by 107.2 over 107.2, you would still get 2.35. Basically because all of those fractions reduce to 1 over 1. So we're going to do that up here. We're going to take this 2.35 and we're going to multiply it by a fraction. And all we have to do is make sure that the top and bottom of the fraction are equal to each other, because when the top and bottom are equal, they cancel out and we get 1 over 1. So I'm going to do this. I knew up here that I'm trying to turn millimeters. I'm going to try and turn them into meters, right? I wanted them to be in this unit. So I have this thing. I can say that 1 meter is equal to 10 to the third millimeters. That's something we're going to call a conversion factor. Right there. I can make 2 different fractions out of this. I can make this fraction. I can make 1 meter divided by 10 to the third millimeters. And because the top and bottom of that fraction are equal, that should just be 1 over 1. Or I could say that 10 to the third. Did I do that wrong? No, yeah, I did that right. It's, I think I wrote it up above us. It's 1 millimeter is 10 to the minus 3 meters. So I just flipped it and made the power of 10. I've done that in my head. Sorry for those of you who didn't follow that. I can also do 10 to the third millimeters is equal to 1 meter. Like so. Either of those fractions will equal 1. I'm going to multiply by one of them here. Now, if you remember from chemistry, if you've never taken chemistry, don't worry, I'll explain it. But essentially, we want to line these up such that our units will cancel. And I'm going to do it like this. I'm going to put 1 meter on top, and I'm going to put 10 to the third millimeters on bottom. You essentially want the unit on bottom to match the unit you started with. Because this fraction, when you multiply all three of these things together, this is exactly like 2.35 over 1, you will get 2.35 millimeters on top times 1 on top. You will get 1 on bottom times 10 to the third. Make that look like a 3 millimeters on bottom. Sorry, that was 1 meter on top. Look what happens. The millimeters cancel out. Because a millimeter divided by a millimeter will go away. And so what I have left with is that 2.35. Ones don't actually make a difference. And I have a 10 to the third on bottom. Whenever you divide by a 10 to the third, you get a 10 to the minus third. So 10s on the bottom are the same as the negative on the top. Negative 10s on the bottom are positive 10s on top. So I'm going to take that and go down here. Pretend that I brought that all the way around, and that is 2.35 times 10 to the minus 3, but I'm going to put, it's now in meters, right, because the millimeters canceled. So I just converted my millimeters into meters. 2.35 millimeters is the same as 2.35 times 10 to the minus third meters. Notice I haven't changed any sig figs. I still have 3 sig figs in my number. Okay, so that's a very basic unit conversion. I take my, and to review, I just take my starting number, and now there's a lot of space, so maybe it'll be less confusing. 2.35 meters was the starting, or millimeters was the starting number, times, and when I do this, I like to fill in the units first. I like to go millimeters first. I know I want my millimeters to be on bottom. I know I want my meters to be on top. And I know that, and if you want to do it like I had up here, right? If you forgot, I will go ahead and use this. It was 1 millimeter was 10 to the minus 3 meters. And that still will work. I'll put it right in here. 1 millimeter is the same as 10 to the minus 3 meters. So as long as the top and the bottom, again, are equal to each other, then I'm multiplying by 1. So what will happen? My millimeters will cancel. I have 2.35 times 10 to the minus 3 on top, over 1, which is not going to change anything. So I'll get 2.35 times 10 to the minus 3, but the leftover unit is meters. So you can call this dimensional analysis, which is the technical name for it. It's exactly the same as a lot of the ways that teachers teach stoichiometry, if you remember stoichiometry from chemistry. All right, basic stuff. We can do this long ways if you wanted to. Let's say you had your let's do a different number actually. Let's do 7.5, and let's this time go from kilometers, but I want to know how many millimeters is that. So my question mark here would be how many millimeters are in 7.5 kilometers. You could do this in 2 steps, if you like. 7.5 kilometers. Up above, I knew that I can convert those to meters very easily. A kilometer down here and a meter up here. I'm trying to cancel this, so I put it on bottom. And I knew that 1 meter is the same as 10 to the let's do it the other way. Let's do 1 kilometer is 10 to the third meters. I know a kilometer is 1,000 meters. Now, if I multiply this out, my kilometers will cancel, but it will give me meters, and that's not my question mark. The question is asking me for millimeters. So I have to keep going. So instead of writing a new equation, I'm just going to do this. I'm going to add it on. I am now in meters, so let me put meters down here so I can cancel those out, because what I really want is millimeters. So I'll put those up top. Okay, now I can remember, I knew that 1 millimeter was a 10 to the minus 3 meters. Good. So if I multiply all of this out, my meters will go away now because I have one on top and one on bottom, and I should be left with millimeters, which is what I was looking for in the first place. So this is, again, very similar to stoichiometry. We line it all up, and then we just kind of chug through it. Well, I've got 7.5 multiplied by 10 to the third, divided by 10 to the minus third. And again, if you have negative 10s on bottom, they become positive 10s on top. So this is the same as a 10 to the third on top. So I have a third on top, another third on top, so I'm going to have 6 10s total. 6 positive 10s. So I'll have 7.5 kilometers, sorry, this is now in millimeters when I'm all done. Hang on, I'm going to put that at the end. No cheating. With 7.5, and then I have 6 10s that are going with it, and the final unit is in millimeters. And I didn't change my sig figs. I still have 2 sig figs. There we go. So that's like a 2-part conversion. 1, 2. It involves 2 conversion factors. And if you knew the conversion factor between kilometers and millimeters, if you knew that 1 kilometer is the same as 10 to the 6th millimeters, fine. You can go ahead and do that in one step. Just more stuff to memorize. Totally okay. The last one that's very common for us is going to be compound units. And one that comes up all the time, and let's just do this here, is converting speeds. So here in America, speed limit on I-41 is something like 65 miles per hour. I'm going to draw it as a fraction, miles divided by hours. That is the speed limit on the freeway. In pretty much every other country in the world, maybe with the exception of Britain, but I think they've converted to metric by this point as well, they use, they want to know your speed in kilometers, not in miles. Now, I'm actually going to go a step further because when we do physics, we're going to get very used to the speed meters per second. So I'm going to say I want to convert 65 miles an hour, and how many meters per second is that? That's going to be my question mark. We can totally do this. So I'll start with my number, 65 miles over hours. Now, I think I have it memorized, but I always check just in case because I don't remember how many miles are in a kilometer. If you don't have that conversion factor memorized, no worries. Most tests will give it to you in case you need it, or you can just Google it if you're doing homework or something. So let's ask Google, how many miles in a kilometer? And apparently so Google spits it out as a conversion factor, and it says 1 kilometer equals 0.621 miles. It actually gives me more digits than that, but 3 sig figs is fine, especially because I'm only starting with 2 anyhow. All right, so I'm going to multiply. I want miles to cancel, and they're on top, so I'm going to put miles on bottom, and I'm changing miles into kilometers, and as long as I make top equal to bottom, I'm good. So what's equal? Well, this is equal. 1 kilometer is equal to 0.621 miles. Come on, decimal place. There you go. Now, that will cancel my miles, but it leaves me with kilometers, and what I wanted on top was meters, so I actually have to keep going. So I'm going to multiply again. I want to get rid of kilometers, so I'm going to put them on bottom. I want meters, so I'm going to put them on top, and I remember from before that 1 kilometer is 10 to the third meters. Okay, now I'm almost done because that will cancel my kilometers and give me meters like I wanted here, but it will not give me seconds. And look at that, I still got hours on the bottom. I want that to be seconds, so I'm going to do one more. Now the tricky part here is that these are on bottom, so if I want to cancel hours, I actually have to put an hours on top so that I have one on top and one on bottom, and they will cancel, which means I'm going to have seconds on bottom. Now, you could do this in 2 steps. You could do hours to minutes, then minutes to seconds. I know they're both 60, so I'm just going to do 60 times 60 is 3,600. So 1 hour is 3,600 seconds. Or if you want, that's 3, well, I'll do that as I work it out here. Now you can plug all this into a calculator. You probably should. When I'm looking through these conversion factors, I look for stuff that cancels easily. That's not a number that cancels easily, that 0.621. So I would put this into a calculator just for speed's sake. But if you can cancel, a lot of times, 10 to the third, you don't have to put that in a calculator. That's just tens. Multiplying by 10 is very easy. And you could also do this. You have 3 tens on top. This number here is the same as 3.6 times 10 to the third here, if you put it in scientific notation. And that's a very quick way to go cancel, and then you're only, I think it makes the calculator work a little faster, I suppose, if you can do it fast enough in your head. So what am I left with? Well, on top I have 65. I have 1. I have 1. I canceled my 10 to the third, so I don't care. So 65 is the only thing on top. On bottom, I have 0.621. I have 1, which I don't care about, and I have 3.6 now that I had changed it to this, right? That's how I canceled my 10 to the third. Okay. Well, let's try that in my calculator. So 65 divided by 0.621, slow calculator, divided by 3.6. And I get something like 29.07. Awesome. And now that the hours have canceled, and I'm left over here, I've got meters top and I've got seconds bottom. So I'm going to have meters per second. So 65 miles an hour, that's freeway speed, is about 29 meters per second, in case you were curious. People ask me, how many sig figs do I keep in that answer? There is a longer explanation, but generally speaking, you keep as many as you started with. So if this was a 2 sig fig number, I'm pretty safe keeping 2 sig figs. So when I round this number, because actually my calculator spit out a much bigger number, it said 29.0749, it just kept going. So if I start with 2 sig figs and I'm multiplying stuff, 2 sig figs is fine for me to keep, and I'll round it to that number. If this was like 29.9 or something, I would round that to 30 and just keep 2 digits. But in general, you are safe keeping about 3 digits. So 29.1 would not have been a terrible answer in this situation if you weren't sure what to keep or not to keep. In general, I'm not going to be too big of a stickler for sig figs. And if you're taking AP Physics, the current AP test, this is 2018, 2019, is not a huge stickler for sig figs. 3 sig figs is a pretty safe bet. Okay, that is our lecture on unit conversions.